last part of this chapter is about modelling. Now, modelling in mathematics is where we use mathematics to solve a real world problem. I think it's to get around the problem of being asked what's the point of doing this. Well, maths is abstract, and what's one of the many beauties of it? You do it for the sake of doing it, for the fun of it, but also we can use maths to solve some problems. So in example 15, and I'm sure this is something you'll be solving quite often in life. It says, a spear is thrown over level ground from the top of a tower. So you're on a tower and you're chucking a spear. The height in metres above the ground after t seconds is modelled by the functions. This time it's a function of t. Of course, it's h of t, h for height. The height of the spear after t seconds is given by 12.25 plus 14.7t minus 4.9. And you'll be used to seeing these values of t squared, these values, because they're multiples, well, sort of 9.8, which we use for gravity. So let's just rewrite it in quadratic order. And the first part of this question asks us for the interpretation of 12.25. Well, 12.25 is the value when t is 0, because when t is 0, that's 0, that's 0. So when you put the input value of 0 in, that's your output. So when t equals 0, h equals 12.25. So it's the initial height. B, after how many seconds does the spear hit the ground? Well, the spear hits the ground when height is 0, so when this is 0. Let's make the quadratic positive. It's just a useful thing to get used to doing. So we could try and factorise it. I don't particularly fancy trying to factorise that though, so we're going to go for the quadratic formula. So that's A, that's B, that's C. So minus B plus minus square root B squared minus 4AC, well, that called the discriminant for the last part of the chapter. That's going to be 14.7 plus minus square root, well, minus 14.7 squared, but obviously when you square it's going to be positive anyway, minus 4 times 4.9 times minus 12.25, all divided by 2a, which is 9.8. So t equals. Now at this point, I wouldn't personally try to put that into the calculator. I would use the equation solver. So on the calculator you go menu, A, 2 for polynomial, degree of 2 because it's quadratic. A was 4.9, B minus 14.7, C minus 12.25. Give me two solutions, then you've got the exact solution and the real decimal solution. 3 sig figs, 3.68. And minus 0.679. Well, obviously that's going to the solution because you can't have a negative value for time. C says to write it in the form of A minus B t minus c squared. It's basically completing the square. So I've got to complete the square of this. Okay. So, first thing I'm going to do then is just split it up. So minus 4.9 t squared plus 14.7t plus 12.25. Just going to deal with this part first. In fact, what I'm going to do is bring minus 4.9 out. So it'll be t squared minus, what's it going to be, 3t. And then if I complete the square, t squared 2, square that, and 9 over 4. So if I times this by 4, it's going to be 50 over 4. So bringing that together, I've got minus 4.9. I didn't need to do that yet because I need to times by 4.9 first. So I need to do 4.9 times 9 over 4, 11.025, and then 2 minus it's when you multiply make a positive, and then plus 12.25. So bringing that together, so rewriting it in the order it wanted it like this. So it's 23.275 minus 4.9 t minus 3 over 2 squared, and it's in that form. So I is this, B is this, C is this. Work out the maximum height. Now it's going to be 23.275, take away this. Now this has to be bigger than or equal to 0, because this has to be bigger than or equal to 0. So the biggest this can ever be is when this part is 0, because you're always going to be subtracting from it. So the max height is going to be 23.275, and that's going to be when this part's equal to 0, when t equals 3 over 2, after 1.5 seconds. Okay, that's all the examples on this chapter. So you can now do exercise 2H plus the mixed exercise.